Good morning. We are in the lab room and I wanted to show you all a little something today. So I got a few things. I had to order them on Amazon and they took a few days to get here. These are ball bearings, which are just steel balls, but the reason we have ball bearings is simply because they're heavy. Um, Heavier than you would expect. Heavier than a marble, heavier than anything else like around this size that you could think of. So they're heavy and we want them to have a greater mass because we want them to have more energy. Remember, mass is directly related to energy because in all of our energy equations, mass is in them. Kinetic energy is 1/2 mass times velocity squared. Potential energy is mass times gravitational acceleration times the height. So the more mass, the more energy. That's the way it is. Now the other thing I had, which I got in the store, is floral foam. What is floral foam? It's that foam that they put flower arrangements in. But why are we using this? It's not like regular styrofoam where you could see the holes. I mean, you could see the holes. They're very, very small. But the reason is because you can squish floral foam, and it'll leave like a dent in it. Can you see the dent I made with my thumb? Maybe. Kind of. And the point is, we're going to drop the ball bearing to hit this because we want it to make a dent. And we're going to drop it from different heights so we can see the different dents that it does make. Okay? All right, let me get everything set up for you. Okay, so we're going to take our meter stick, and I have the fluorofoam right here. Hopefully you can see the little green there. And I'm just going to drop this from different heights. Now, in the lab document, they originally had us dropping it from 20 centimeters and 80 centimeters. And we can do that, but proportionally, I'm going to instead drop it from 50 centimeters, 100 centimeters, and then 200. That'll allow us to see the indentation because the more height, the more energy. So hopefully it'll make a bigger indentation for us. So anyhow, of course we would it's not so bad, although it takes a little bit of practice to get it just right. Set this up at 50. You wouldn't want to put it directly against this because it would hit the ruler going down. But hold it out a little bit and you just drop it. And then I was checking to make sure I know which one is which, and I do mark them as I go. Then, of course, I'll move along the phone. Oh, jeez. Hold on. I'll move along the phone to a different spot, and this time I'm going to drop it from 1 meter. And it's going to make a different size dent. Now, dropping from 2 meters takes a little bit more effort, so I'm going to do that without the video showing. But I want you to just look. This is the 50 centimeters. This is the 100 centimeters of the 1 meter. And we're going to cut the foam open so you can actually see the depth of these. Okay? So I'm going to pause this video and we will continue and cut open the foam. Okay, everyone, I've now relocated to the kitchen. And you could see that when I was dropping from 2 meters, I was having a hard time actually hitting the foam because you have to like hold the meter stick really straight to make sure that you hit it. I hit it on the edge a lot of times. Anyhow, this is the 50 centimeters, this is the 1 meter, and this is the 2 meters, or the 200 centimeters. So I'm going to use a knife to cut them open so that we could actually measure the depth of the holes. All right, hold on. Okay, back again. So now you can really see the depth, although I didn't cut this the best. So this is the 50 centimeter one. It's actually really hard to see, but it's right there. Can you see how it dips down a little bit right there? See the little dip? Yeah. And this is why I didn't do 20 centimeters because I don't think it would have made a big enough indentation for us to measure. Here is the 1 meter. You see it right there? Here you can see it when I put it at an angle, a little bit better. And then here is the 2 meter divot. Now you could really see this one. This one made a really nice hole right there. Okay, so I'm going to take the ruler, the meter stick, and of course measure these. And you could see that the first one was only about it was like 1 milliliter. It wasn't a lot at all. Then This one probably goes maybe to about 3 or so I said milliliters, I'm sorry, I meant millimeters. Excuse me. About 3 millimeters. And this one probably goes up to about 7 or 8. Now I'm going to go upstairs and take more accurate measurements. So what you're going to see on your lab document are going to be the accurate measurements that I have taken. But you could see the divots made. The divots are going to be directly related to the amount of potential energy that it had at the top. So the higher up it went, it had more potential energy. As it fell from the higher the height that it fell from, it would gain speed, velocity, and it would have impacted with a greater velocity, each one of them. And that's why the divot or the welt that the ball bearing made when it hit the foam is going to be was increasingly larger as the height and the velocity increased. So you can see it's all related. Anyhow, I'm going to go upstairs, get some measurements. I will put that in that document so that you can do your questions. All right. Have a good day. I hope you enjoyed this lab.